In quantitative aptitude, we'll see in this session about number system. So I'll explain in this 1 hour video the complete information about some shortcut tricks with the number system and some of the numbers. We'll see the prime numbers and prime factors. Again, that's some divisibility rules. Along with that, you'll see the factors and multiples of numbers. So let me explain the topic wise one by one in this. So everything is completely short tricks instead of doing the long process. So okay, for example, the first problem. The question is related to the number system. So what is the sum of the natural numbers from 1 to 100? Sum of natural numbers from 1 to 100. So without adding 1, 2, 3, so on up to 100, we have to find out the sum of these numbers. So I'll give the shortcut formula for this. S is equals to, that is sum, is equals to n into n plus 1 by 2. So here n is the number of natural numbers. How many numbers we need from 1 to 100 or 1 to 50? If it is 1 to 100, n is equal to 100. The 1 to 200, then n is equals to 200. That is 100 into 100 plus 1 and divide by 2. So 2 ones are 250 is a 50 into 100 plus 1 is 101. So that is 5050. So sum of the natural numbers from 1 to 100 is 5050. So this is the sigma n formula it is. So in general in intermediate you'll learn this. Sigma n is sum of the natural numbers. That is equals to n into n plus 1 by 2. So this is the formula we can use for to finding the natural numbers from starting from 1. Okay, find the sum of the natural numbers from 101 to 201 if they ask like this. The question is find the sum of natural numbers from 101 to 200. So in this question it is not asking from the 1 itself. So previous formula only if the question is asked from 1 to certain number, so we'll use it. Now in this question they're asking from 101 to 200. So what we can take from the total 200, if you subtract first 100 sum, then you'll get it. So we don't have any direct formula for this, but if you want the shortcut method for this 101 to 100, so what we can take, we'll do the sum of 1 to 200. From this we just subtract 1 to 100 sum. Okay, sum from 1 to 100, 1 to 200, and we'll subtract this sum 1 to 100. It's easy. So 200 is 200 into 201, next number by 2, minus 100 into 101 by 2, that is 2 into 100, so 20100, 20,100 minus this we just calculated, 50 into 1 is 5050. Then we go for subtraction. So 20,100 subtract 5050, okay, that is 15,050. So this method you can use to find out this directly. So this is the formula for sum of the natural numbers. Next, instead of natural numbers, if the question is asked about even numbers or odd numbers, let us see the one more. Find the sum of the even numbers from 1 to 100. Find the sum of even numbers from 1 to 100. So from 1 to 100, how many even numbers are there? That we should know. N is equals to always number of digits. That means either 2, 4. So number of given data, that is equals to N. So from 1 to 100, the even numbers 2, 4, 6, 8, so on, and even that 100 also. Not between, they asked 1 to 100. So 2, 4, 6, 8 is all total, there is 50. So N is equals to 50. So there are 50 even numbers are there between from 1 to 100. Now for this formula is S is equals to N into N plus 1. Yeah. This formula is only for even numbers. That is equals to 50 into 50 plus 1. So 50 into 51, we can multiply 2550. So 2550 even number, sum of the even numbers from 1 to 100. So this formula you can use for the even numbers. Find the sum of the odd numbers from 1 to 100. Then odd numbers formula and view. So even numbers is N into N plus 1. Find the sum of odd numbers from, okay, 1 to, I'll take 150. So 1 to 150, how many odd numbers are there? So in this, we need to find out the value of N. So N is equals to 75, because half of them, 1 to 150, there are 75 odd numbers. 1 to 100 is 50 odd numbers. 1 to 150, 75 odd numbers. So 75 odd numbers are there. So formula is S is equals to, this is for sum of the odd numbers. S is equals to N square. So this is formula for odd numbers we'll use. That is 75 whole square. So 75 into 75. Just will multiply 5625. This is sum of the odd numbers from 1 to 150. So we need to check how many exactly odd numbers will come, how many even numbers will come. So based on that. So for example, okay, odd numbers between 1 to 300. 1 to 300 odd numbers N is equals to 150. This is 150. 1 to 300 N is equals to 150 odd numbers are there. If the question is asked about 1 to 251, then N is equals to, we can take 126 odd numbers, because 251 is also added. Up to 250, 125, half of them, but 251, right? So 126. We need to check exactly what is the N value. Then you can apply these three formulas. Okay, sigma N. This for natural numbers. N into N plus 1 by 2. Sigma N. If it is even, number of even numbers, then N into N plus 1. Sigma N. If it is odd numbers, then N square. Okay, these three formulas you'll use for short trick for finding the sum. Next, squares and cubes. Okay, natural numbers. Find the sum of 1 square plus 2 square plus 3 square plus 4 square plus so on plus 100 square is equals to dash. So this is sum of the squares of the natural numbers. Similarly, sum of the cubes of the natural numbers. 1 cube plus 2 cube plus 3 cube plus 4 cube plus so on plus n cube. So n is any number. Okay, the previous example also you can take n. 100 square. So n they will give the in the problem. Now n square. So this is for sigma n square. Sigma n square. So this is a symbol sigma. Sigma is nothing but sum. So sum of the squares of the natural numbers. So we can denote like sigma n square. So sigma n square is n into n plus 1 into 2n plus 1 by 6. This is the formula for sum of the squares of the natural numbers. Now sigma n cube, sum of the cubes of the natural numbers. Sum of the cubes of the natural numbers is n square into n plus 1 square by 4. Or we can write n into n plus 1 by 2 whole square. Or actually n into n plus 1 by 2 is a sigma n, right? Previous you have seen. So sigma n whole square. So sum of the natural numbers whole square is sigma n cube. Let us check with example. Now 1 square plus 2 square plus 3 square is equal to dash. So without using formula, if you find what you'll get, 1 square is 1, 2 square is 4, 3 square is 9. That is equals to 14. If you apply formula, n is equal to 3. So shortcut is n is equal to 3, right? So 3 into 3 plus 1 into 2 into 3, that is 6 plus 1 by 6. 3 into 3 plus 1 is 4 into 6 plus 1 is 7 by 6. 3 ones are 3 twos are and 2 ones are 2 twos are. 7 twos are 14. Yeah, same thing we'll get. So this is a formula you can apply for sigma and cube. Even for cubes also. For example, 1 cube plus 2 cube plus 3 cube. That is equal to n into n plus 1. 3 into 3 plus 1 by 2 whole square. 3 into 4 by 2 whole square. 2 to the 4, 3 to the 6. 6 square is 36. Even if you apply 1 cube is 1, 2 cube is 8, 3 cube is 27. Same, you'll get 36. Okay, this is for some of the squares of the natural numbers and some of the cubes of the natural numbers will apply these two formulas. Okay, so based on this, in different one more question, I'll write question here. If 1 square plus 2 square plus 3 square plus so on plus 10 square is equals to 385, if then 2 square plus 1 square 2 square 3 square, okay, then 2 square plus 4 square plus 6 square plus so on up to 20 square is equals to dash. 1 square 2 square 3 square up to 10 square is given. Then we have to find out 2 square 4 square 6 square so on up to plus 20 square. 2 square, so what we need to find out, that will write. So I'll solve problem like this. I have to find out value of 2 square plus 4 square plus 6 square plus 8 square plus so on, plus 20 square is equals to dash. So just to split this part, 2 I can write 1 into 2 square, plus 4 I can write 2 into 2 square, plus 6 2 into 3, because everything is multiple of 2, plus 2 into 4 square, plus so on, plus 2 into 10 whole square. Now you separate the squares. Now overall, if you take 2 square common, from first part is 2 square plus 2 square plus 3 square plus 4 square, because 2 into 4, right? 2 square and 4 square, plus so on, plus 10 square. So 2 square is 4, and this value is given 385, that is 1540. We can write this. So 2 square, if you are able to split, so you can make in this way. So simultaneously they'll give in these questions. Now we'll see about the prime numbers. So such type of questions for sum of the numbers. Now we'll see prime number concept. So how many prime, what is a prime number first? So what is prime? If a number is not divisible by any number except 1 and itself is a prime. So if you take number 5, 5 I can write only 1 into 5 or 5 into 1. So I can't write more than this. So 5 is the prime number. If you take 6, 6 I can write 1 into 6, again 2 into 3 also. So this is not the, so 6 is not a prime number. So factors of that number should be only 1 and itself is a prime number. So how many prime numbers are there between 1 to 100? So in exam point of view question, the most of the questions will ask about the prime numbers. So I'll write the list here. So number of primes between from 1 to 100. So I'll write list. Prime numbers from 1 to 100. So no factors except 1 and itself. The first prime number is 2. So 2 is only the even prime number. Remaining all the prime numbers will get odd numbers. Only 2 is the even prime number. 2, 3, 5, 7. So they don't have any other factors except 1 and itself. And 11, 13, 17, 19. So if you observe, there is no any factors except them. Then 23, 29, 31, 37, 41, 43, then 47. Again 48 is divisible by 2. 49, 7 7 is 49. Again 50 is also divisible by 2. 51 is divisible by 3. 52 is not. Next 53. 53, then 59, 61, 71, 73, then take 79, 83, 89, 97. These are the prime numbers from 1 to 100. 3, 4, 5, 6, 7, 8, 9. And if you count the total, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So there are 15 prime numbers between 1 to 50. Again 1 to 50 15, 1 to 100 25. So this is 53, 59, in 61, 62, 63. They are all not primes. 71, 67. We can take 67 also, right? Yeah. 67. So these are the prime numbers. Now based on this we can make an order the primes from 1 to 100. So 1 to 100 prime numbers are 25 because total prime numbers from 1 to 100 is 25. 1 to 50 prime numbers are 15. Then 51 to 100 is 10. So you can make the data like this. So these are the 25 prime numbers, the total. So 51 to 100. In the question if they ask problem 51 to 100 primes. So from total 25 the first 50 is 15. If you subtract, so 10 prime numbers between 51 to 100. We can use this type of any questions arised. So these are all the 25 prime numbers between 1 from 1 to 100. So let us see about some more questions related to the prime numbers. And the least prime number is 2 and the least even prime number also is 2. Okay, then the even prime number is also 2. So regarding the 2, many questions can come in exams. This 2 is the least prime number as well as the even prime number is also 2. And single digits prime numbers are only 4, 2, 3, 5, 7. And 2 digit largest prime number is 97. So based on these 25, so questions can come. Now we'll see the co-prime and twin prime. Co-prime and twin primes. So co-prime is if there is no common factor between the two numbers, then are the co-primes. So for this, no common factor. So they need not to be prime numbers. Co-primes, many of you confuse. Co-primes are they need not be prime number, but there is no common factor between the numbers. So for example, if I take 21, okay, 15, 28. 15 and 28 are co-primes or not, because 15 factors are 1, 3, 5, 15, because this 15 is in one table, 3 table, 5 table and 15 table. And 28 factors are 1, so except 1, because 1 is a common for all, except 1, then 2, 4, again 7, 14, 28. In this there is no common factor except 1, so no common factor except 1. Then there is a co-primes. So 15 comma 28 are co-primes. When you come to the twin primes, the difference between the prime numbers is 2. Here difference between prime numbers is 2. So in twin primes concept there should be prime numbers. If you see 3 comma 5, example 3 comma 5 are the twin primes, both are prime number and difference between the prime numbers is 2. So what you can write if you observe in this example, prime numbers difference must be 2. 3 comma 5, even 5 comma 7, 11 comma 13, because gap is only difference is 2. Still 41 43, also twin primes. Again, yeah, 71 73, also twin primes, because difference between the prime numbers is 2. They are called twin primes. 71 73, also twin primes. 5 comma 7 or twin primes. So co-prime is different and twin primes is different. Co-prime is no common factor except 1 between the numbers, but twin primes is difference between the prime number is 2. Okay, then, so regarding numbers, the one more important thing is just a simple question: face value and place value. Face value and place value. In 35,000, okay, 3 lakhs 57,569. In this one, face value of 7. Face value of 7 is only 7 only we can write, because the value of the place, the face, the particular, the value of the number is 7, but place value of 7 is 7,000 we write. Okay, place value is 7,000, but face value is 7 itself. Face value direct that number. Now if you take, what is the face value of 3? Face value of 3 is 3 itself, but the place value only after 3, next we have 5 digits, so 5 zeros, that is 3 lakhs. Face value, this is a place value. Place value, we can know that in the question itself the meaning is there: ones, tens, hundreds, thousands, so 7,000 is the place. Place value of 6 is 60, but face value of 6 means 6 itself. So this is the difference between place value and of face value. Now we'll see the prime factors. Prime factors, a number of prime factors. So many questions will come regarding this prime factors from this number system. So many factors from this. Okay, I'll explain you prime factors. So prime numbers as the factors, we can take it as the prime factors. 15 to the power 6 into 12 to the power 10 into 51 to the power 5. So in this number, how many prime numbers are the as factors? Then in that case we have to split into the product of the primes. So 15 is not prime and 12 is not prime, 51 is also not prime, but we can write as the product of the primes. This 15 we can split 3 into 5, product of the primes, 3 and 5. 12 we can write 3 4, 3 into 4, again 4 also we can make it as 2 into 2, that is completely 3 into 2 into 2 is 3 into 5. So 51, that is the product of the primes is 17 into 3. So overall prime numbers are used in this 3 comma 5, 2 are there, 3 comma 2 comma 2, 3 are there, 17 comma 3, 2 are there. So but 2 is 3 are common. Finally 2, 3, 5, 17 are prime factors. So there are this of 3, 4 are the prime factors. If any question is given, you have to split that number into the prime factors. Okay, I'll give you one more example. Find number of prime factors in 15 to the power 6. Okay, same thing if you take, okay, one more example, 10 to the power 3, 45 to the power 6, 30 to the power 10. So how many prime factors as the base they are used? So we need to split this in the form of product of the primes, that is 2 into 5. Both are prime numbers, but 45, 3, 5, 3, 3 5 is a 15, 15 3 is a 45. Completely we need prime numbers. Factors should be prime. 30, 2 5 is a 10, one more. So 2 5, 2 5 is a 10, 10 3 is a 30, 2 5 3. Finally we have only 2 comma 3 comma 5. These are the factors. So only 3 are the factors are used. In this total product base we can get only 2, 3, 5 are the product of the factors. So these are related to the factors. Now we'll see divisibility rules. So these divisibility rules are very important in this number system. So I'll explain you all the divisibility rules in easy manner. So we'll see all the single digit divisibility rules will explain you first. Yeah. Divisibility rules in shortcut I'll explain. 2, 3, 4, 5, 6, 7, 8, 9. See, for single digit numbers we'll see the divisibility rules. For 2, that number should be even number. So even digit should be in the units place. Then that number is divisible by 2. Okay, example, if you take 148. So this is units place. Unit digit should be even digit. Then it is divisible by 2. For 3, sum of the digits. So sum of the digits should be divisible by 3. Example, if you take 156, 1 plus 5 plus 6, 12. So 12 is divisible by 3. Then that 156 also divisible by 3. So briefly I am explaining. So there is one more video in my channel about divisibility rules. You can see each and everything in complete manner, because I am only concentrating the problems which are related to divisibility rules. So you can see there is a link in description, so that you click and you can see the clear concept about divisibility rules all from 2 to 13. So in that I explain up to 20 also. So 2 to 20 rules are there, you can see in that video. So in briefly I am going to explain here. For 4 we need to check last 2 digits. If last two digits are divisible by 4, then that number is divisible by 4. If 148, 48 should be divisible by 4. Then 148 also divisible by 4. For 5, units place should be either 0 or 5. Units digit is 0 or 5. Then that number is divisible by 5. For rule for 6 is we need to check for rule of 2 and 3. If it is divisible by 2 and 3, then that number is divisible by 6. For 8 also we check last 3 digits. Last 3 digits should be divisible by 8. And for 9, again some same rule for 3, but sum should be equals sum of digits. You do addition of all the digits, then that number is divisible by 9. Then the total number also divisible by 9. 7 also is explained in some description video is there that you click and you can watch that. So because in that complete divisible rules I explained briefly in that video. So I'll continue this lesson with the concept of using the divisibility rules. To learn about complete information about divisibility rules, you can click in the link in description and you can watch it. Now questions will come like this. The first of all problems which are related to the divisibility rules. I'll explain you now. 2, 3, 4 star 6 is a factor of 9 or is a multiple of 9, or this is divisible by 9. Is multiple of 9. Then what is the value of the star symbol? In this place what should come? So 9 rule we should know. So rule for 9 is sum of the digits should be divisible by 9. Then what we can take, we just to add all the digits. 2 plus 3 plus 4 plus some star plus 6. The symbol we need to find out. 2 plus 3 5, 5 plus 4 9, again 9 plus 6, 15 plus some symbol. So it should be divisible by 9. So 15 plus, then what number if I write that is divisible by 9? So in 9 table, again 9 2s are 18. So we need compulsory 3 here. So 18 is divisible by 9. So the star is the place is 3. If you add the remaining digits, then you can find out exactly what you'll get. So they ask for even for 11, some other numbers also. Then for 11, if you check 3 0 and the symbols 0 3 0 1 is multiple of 11. Then this is equal star place, in the place of the star symbol what digit will come. So given options 8 7 4 and 9. We should know the rule for 11. So rule for 11 is the difference of the even and odd places should be either 0 or multiple of 11. So I'll explain you. If you know the rule for 11, so you can understand this. 3 0 star symbol 0 3 0 1. So alternate numbers we need to add. Alternate numbers. This is one set and another is these numbers, even places and odd places. Odd places and even places. Sum of the even and odd places. So odd places are 3 plus that star plus again 3 plus 1. This is 0 plus 0 plus 0. that is 3 plus 3 6, 7 plus some star is there, this is 0, but these difference should be 0 or 11. These difference should be either 0 or 11. So there should, you should keep in the place of star 4 because unit sum should be 11. 0 there is no chance because already number is there. Now 7 plus 4 in this star place, if I keep 4, then the star place is equals to 4. If you keep 4, then 7 plus 4 is equal to 11. So this is 11 and this value is 0. So 11 minus 0 is 11 itself. Either 0 or 11 should come, this difference. So the star is equals to 4. So option C is the correct. You can explain this. So I'll explain other two more problems which are related to this. Now question is, this is very important. In the, what is the units place in the following number? Okay, I'll write question. What is units place in the following product? So that is 233 into 462, 574, 967, 858 and 339. So if you multiply this whole number, this total number, what is the number in the units place? That is the question. So instead of multiplying the total, so it's not at all so easy to multiply each and every number, it's come so big. For that we need to just multiply the units places. Now units places are 3, 6, 3, 2, 4, 7, 8 and 9. We have multiplied 3, 2, 4, 7, 8, 9. Even without multiplying that much process, just we will multiply first all the units place. So 3 into 2, that is 6. Okay. Again units place only multiplying. Again 6 into 4, 24. So don't take 2 now. Again we should take the units place. Always we should take only the place of units. Now don't take this 2 and now take only 4. Then 4 into 7, 28. Okay. Now again you cut this tens place. Again 8 into this 8, 64. Now cut this 6. Again 4 into 9, that is 36. In this cut 3, finally answer is 6. So 6 is the units place in this total number. Only you have to take the single digit. So only units place you should take. Okay, I'll explain one more problem. Same, what is the units place in the following product? Now product is this 223, 446 and 758 into 954, 989. So what is the units place? What number is in units place? What number in its units place? So this is, we are going to check now. So according to the method, we have to check only the units places. That is 3, 6, 8, 4 and 9. So you can start multiplying from here. 3 into 6. We are getting 2-digit number, that is 18. In this, cut 18, or now only take 8. Again 18 to 8. 64. Now take only units place, 4. Again 4 into 4. 16. Now take only 6. Again 6 into 9. So that is the 54. 54 only the 4. So finally answer is equals to 4. We'll take only units place and we'll continue like this. Okay, this is one method. And similar type of question they may ask this method. This is the last problem I'm explaining. They'll give one number, if they miss. So what will the units place? If they'll give units place and one number is missed, how will get? So I'll write the question. If the units place in the following product is 4, if the units place in the following product is 4, then find the value in the place of the star. So I'll write the product down. Yeah. So question is 111, 222 into 222 into 333 into 444 into 5 and this is the star. One unit is there that you have to find out. Into 66 into 77 into 88 into 999. So if in this product, what is the value in the place of star? So we should take the same concept. We'll take only units place. So where is the star symbol? That number don't consider. You take the remaining numbers first. Now the pattern first 1 into 2. 2 it is. Again 2 into 3. 6. Okay, 6 into 4. 24. Now cut this 2. Again 4 into 6. Again 24. Cut this 4. Again 4 into 7. 28. Cut 2. Again 8 into 8. 64. Cut this 6. Again 4 into 9. That is 36. Now the symbol which is having star is 5 star. Now finally 36 into 5 star. Now 6 into something, you should get units place 4. Now 6 into what number will get? Units place must be 4. So you can check 1. 6 into 1, 6 into 2, 6 into 3, 6 into 4. 6 into 1 is 6. So this is not. 6 2 is a 12. 2 is, this also is not. 18. 8 is coming now. 6 4 is a 24. Now this is the units place is 4. So the star place is nothing but 4. No, answer is 4. Still not only for any other number, because we need only units place 4, right? You can continue. 6 into 5, 30. 0. 6 into 6, 36. 6 is there. Again 42. 2 is not required. 6 8 is 48. Again if you take 6 into 9, 54. So you're getting 4. So even there's a chance for 9 also. So 4 or 9. But question, if they ask what is the smallest or what is the least, then they can't do that, you can write. The question is asked what is the least number. If the least is 4, so what is the maximum highest value is 9. So there are chance of 4 comma 9. So according to options we can make it. So 9 we can add as well as 4. That means in the place of 55 star, if it is 554 or 559, in place of this also we'll get same 4 is as the units place. We'll get the same. So the divisibility rules videos are there, you can check in the description. And there are many problems which are related to the same number system. So in the same method, and I'll show you one website here. In this description, this website link is there. You just to click on the link, and there is ICSE, CBSE, SSE, and Inter, which is related to the any other boards also. The papers are available. And click in the description this link, and you can see the same content which I explained, which are related to that. There is some question papers, and the material also is available. So click on see the material, and complete information is available from this number system. So not only this, anything which is related to the quantitative aptitude, you can find out the videos and complete notes. Okay, before that you please subscribe this channel, because we upload only the videos which is related to the educational. I hope you understood well, and if anything information is there, you please comment in the description below that box and share with your friends. I hope you understood well, and thank you for watching this video. Have a nice bye bye.